This is Betty.
Hello?
As you can see, she's very friendly. It was easy to get some video of her wagging her tail because, you know, you've only got to walk towards her and she gets all excited to see you. And for some time I've been wondering, does that tail of hers perform simple harmonic motion when it wags? Using the wonderfully convenient dimple-shaped hole thing at the base of her tail made finding the tail's equilibrium position really straightforward. I decided that it would be best if Betty was horizontal, so I added a reference line and simply rotated her. I used software filters to remove dog bottom wobble and camera shake and then slowed the film down to 25%. As you'd expect, Betty clearly shows variation in how she wags her tail. However, in order for Betty to be performing simple harmonic motion, she'll need to be displacing her tail equal amounts up and down. And I think Betty is actually doing this, although of course not consistently. So far then, let's give her a tick. Well done, Betty. If Betty wants another tick, we're going to have to get some firmer data. But generating a distance time graph for the tip of her tail was just too hard. Plan B then was to take something I know for certain is doing SHM and use that as a reference point. As you can see, Betty's tail and the pendulum bob move along quite nicely together, although they go in and out of phase a bit. There is a point though where for about 2 cycles they match really well. Let's see those 2 cycles again. And here's another short section where they appear to stay in phase quite nicely. I think we can say at times when Betty is wagging her tail, she is doing simple harmonic motion, although of course it's not consistent. Who would have guessed? Now that we've explored the simple harmonic motion of Betty's tail, perhaps you'd find this interesting video worth a look.